Hi guys, let's do remove linked list elements. So we're given the head of a linked list in an integer val, and they want us to remove all the nodes of the linked list that has node.val equal to val and return the new head. So in example 1 down here, we are given this linked list and val equals 6. So since we have two nodes in this linked list with a value of 6, we remove those two and we return the resulting linked list. And in example 2, we have an empty linked list with val equal to 1, and since the linked list is empty, we just return the empty linked list. There's nothing to remove there. In example 3, we're given a linked list with all 7s and val equals 7, so because every single node has a value of 7, we remove every node and we return an empty linked list. So in this one, we're going to want to, well, first, let's take care of the edge case, right? So if we have a linked list where the head is pointing at a node that is equal to val, then we're going to want to move the head until we're at a point where it is not equal to val anymore. Or if it's null, like in this case, we have nothing that has a value that's not equal to val. So like once we loop all the way through and get to the end, then that's just it. And then like there's nothing to remove. But either way, so while our head is not null and head.val is val, so like, right, because while each node is equal to 7, we're going to want to move the head over until it's not anymore. So we'll just move head to head.next. And then for our like regular cases, like example 1, we just want to loop through the linked list and compare the values. So we're going to create a dummy node so that we don't lose reference to the head. Oops. And then while our node is not null, and I'm going to do node.next is not null because I'm going to use node here as like our previous node, because when we traverse through here and we check if 6, like this node with a 6 has a value equal to val, which is 6, and it does, then we actually need a reference to the previous node before it so that we can reassign this pointer to point to 3 instead of 6. And so we just skip over the 6, and the 6, which was the node that we were at, gets basically deleted. So because we need the previous node, I'm basically using node here as the previous node, and then I'm going to use node.next as the actual node that we're at. So I'm going to that way if I can compare node.next instead, and then if node.next value equals val, then I'll reassign node, which is the previous one, to node.next.next basically. Does that make sense? So okay, well, I'll just do it and then hopefully it'll make sense. So if our node.next.val equals val, then we're going to reassign node.next to node.next.next. So that's what I was talking about here. So node, let me show y'all. So 1, 2, 6, 3, 4, 5, 6. So, okay, this is our head, and then we start off with node at our head. So node is here starting out, and then we iterate through. So the first iteration, it's not null in node.next, which is 2 is not null. So our node.next is 2. I'm just going to use n for node and next for the next one because I don't have space here. But node.next is not equal to val, so we don't do anything yet. And then if it's not equal, then we need to just iterate it to the next one. So node equals node.next. So then we're just going to move them along like that. And then is node.next.val equal to val? In this case, so now it is because we just moved them each forward one, right? Because when node equals node.next, then node.next also moves. So 6 is equal to val because val is 6. Then we reassign node.next to node.next.next. So this 2 now points at the 3. And then because it's pointing at the 3, then the 6 just gets taken out basically like that. And then next automatically is just 3 because that's node.next. Okay, and then so we don't do the else, we just keep node here. And then the next iteration then is node.next equal to val. No, it's not anymore. So we just go into the else statement and then move them each like that. Okay, and then the next one, 4 is not equal to 6, so we just move them along again. And then 5 is not 6, so we move them along again. And then now 6 is equal to 6, so node.next equals node.next.next. So the 5 is going to point to whatever is after the 6, which is null. So the 5 will point at null, and then the 6 gets removed. And then now next is pointing at null. So then once we're done, because now node.next is null, so we exit the loop, then we have reached the end, and then we just want to return head. So the time complexity is O of n, because if we think about our algorithm, right, we are just looping through the linked list and visiting every single node once. Or at least once, I should say, because if there's duplicates, then we might stay at the same node. But basically, it's like linear to O of n. So we just say O of n, where n is the number of nodes in the linked list. And then we can also see this in the while loop. So if we have this edge case here, then we basically just do this loop until we reach the end, which is still O of n because we still need to visit every node to delete it or move the head along. And then if it's not an edge case like example 1, then we use this loop instead. And then that is still visiting every single node once here because we're moving node along through the linked list. And then our space complexity is O of 1. It's constant because we only have this one list node here. There's no additional data structures. So that's it for this problem. I thank you guys for watching and let me know what I should do next. Bye.